Our next lesson is on the percent of error, and the purpose of this lesson is to understand the difference between absolute error and percent of error, and then how to use the percent of error equation. So let's first talk about the difference of those terms. Absolute error is the difference of the approximate value A and the exact value X. So remember in math, the absolute value symbol means the distance from 0 on the number line, and you can never have a negative distance. So when you see that absolute value symbol, it's always going to change your answer to positive. The percent of error is a ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. And we're going to use the percent equation to find the percent of error. And we're going to talk about that later in the video. So our first example says, the length of the diagonal of a computer monitor screen tells the screen's size. The diagonal of the computer monitor is 15 inches. 3 students were selected to measure the diagonal of the 15-inch screen with their ruler. Below is a table of measurements each student recorded. So our students are Taylor, Kellen, and John. A shout out to those 3 students. And their measurements were 15 and 2/8, 15 and 4/8, and 14 and 6/8 inches. These are going to be considered the approximate value because it told us right here in the word problem that the exact value of that diagonal is 15 inches. So the first problem in your notes asks the question, do you believe that the stated size of the screen printed on the box is the actual size of the screen? Go ahead and pause the video to reply to that question. Okay, let's see what you said. Did you say yes? Yes, it is the actual size because it would not be right to print one thing when the actual size is something else. That would be considered false advertisement. So let's talk about what absolute error is and how to find it. So remember, for absolute error, we're going to use that equation where we find the difference of the approximate value and the exact value. So for this problem, Taylor's approximate measurement was 15 and 2/8 inches minus the exact measurement of that diagonal, which was 15 inches. Now don't forget, you have to put that inside the absolute value symbol, which will change your answer to positive. So her absolute error was 1/4 of an inch, or 25 hundredths if you change that to a decimal. Kellen's approximate measurement was 15 and 4/8 inches minus the exact. So his absolute error was 1/2, or 5/10 if you write that as a decimal. And finally, John, his approximate measurement was 14 and 6/8 inches minus the exact 15. Now here you're going to get a negative answer, but because it's in the absolute value symbol, your answer is going to change to positive. So his absolute error is also 1/4, or 25 hundredths. Now, explain what the absolute error means in the context of the problem. What that's asking is, what does this number, and this number mean in this problem? So I have already written those responses for you. So go ahead and just pause the video and record those answers. All right, so Taylor, her measurement was 25 hundredths of an inch off the actual value. Kellen, his measurement was 1/2 of an inch off of the actual value. And John's measurement was 25 hundredths of an inch off of the actual value. So that's what absolute error means. And now we're going to talk about percent of error. And that's a little bit different than absolute error because this is represented as a percent instead of a number. So finding the percent of error, we're going to use the absolute error that we used above divided by the exact value. And we have to multiply by 100 because remember in math, to change a decimal to a percent, we multiply by 100. Now we don't have to find out the absolute error because we already did that above. So we already know Taylor's absolute error was 25 hundredths of an inch. And if we divide that by the exact value of the diagonal and multiply by 100, we'll get her percent of error. And that's 1 2/3%. Or if you want to write that as a decimal, that'd be 1.6 repeating. Kellen's absolute error was 1/2 of an inch divided by the exact value times 100. So Kellen's percent of error was 3 1/3%, or as a decimal, 3.3 repeating percent. And finally, John, remember his absolute error was also 25 hundredths divided by the exact times 100. So John also has a 1 2/3% error, or 1.6 repeating percent error. Now we're going to explain what the percent of error means. Now this is different than the absolute error, because for absolute error we got a number. Now for percent error we're going to get a percent. So go ahead and pause the video and record those responses. Alright, so Taylor, her approximate measurement was 1 2/3% of the actual. Kellen's approximate measurement was 3 1/3% of the actual value, and then John, he also had a 1 2/3% error of the actual value. So that's what percent of error means in the context of this problem. And then what is the purpose of finding the percent of error? Well, let's go ahead and use two real-life examples here. The percent of error tells you how big your error is compared to the true value, or another word for that, the exact value. An error of 1 centimeter is really small if we're talking about the distance of a marathon, but an error of 1 centimeter is very large if you're talking about a heart surgeon. So it's really important to identify that percent of error. The last part of our notes, I'm going to do one example with you, and then you're going to try 2 on your own. So example 2, you guess that there are 300 gumballs in a jar, but there are actually 400 gumballs. Find the percent of error. Well, we have to remember that percent of error equation. And remember that's the absolute error. And to find absolute error, you do the approximate minus the exact in the absolute value symbol. And then we're going to divide by the exact value. And finally multiply by 100 to change it to a percent. So here, the approximate value is going to be the guess of 300 gumballs. And the exact value, it told us there were actually 400 gumballs in the jar. And we're going to divide that by the exact value. Now remember, all of that is inside the absolute value symbol. And then we're going to multiply by 100. So for this, when you type that in your calculator, you should get a 25% error. Alright, there's only 2 problems left, and I want you to try those. So pause the video to try those last 2 examples. Alright, let's see how you did. So for Sean, his approximate value, or the estimate, was 13.5 feet minus the exact distance, which was the 15, divided by the exact, and we're going to multiply that by 100 to change it to a percent. So for this one, you should have got a negative 1.5 feet, but you can't have a negative distance, remember. So we're going to put that in the absolute value symbol, and that changes to a positive 1.5. And we're going to divide that by the exact 15, and then multiply by 100. So hopefully for that one you got a 10% error. Did you get that? Excellent. All right, and the last one. Izzy estimates the weight of her Cavapoo to be 17 pounds. The actual weight of her dog is 20.75 pounds. So the approximate would be her estimate, the 17 pounds, minus the actual weight of her dog, 20.75, and that goes inside the absolute value symbol, divided by the exact, times 100. So for here, you would have got a negative 3.75 pounds, but we want to do the absolute value of that. So that's going to change that negative 3.75 to a positive, and we're going to multiply by 100. Now here, you're going to get a long decimal on your calculator. So we can just round that to 18.1%. Or if you want to round it to the nearest whole number, because it didn't tell us exactly what to round to, that would be an 18% error. So either one of those would be an acceptable answer. So how'd you do on that one? Awesome. Well, thanks again for watching the video, and we will see you next time. Ta-ta for now.